All right, guys, so today what we're going to do is we're going straight into multi-step. Your book, though, in advance, what it does is it takes equations and inequalities, just puts it all into one when we're talking about multi-step. So you have to be extremely careful during this time, though, to be able to just watch for that sign, right? I've told you guys when we're dealing with equations, you write a solution, make sure you have the variable, your solution, but also the correct sign too. This is one of those assignments, all right? But one of the many things we're going to learn. So here we go. We have a few vocab words. So everyone has green on the left, notes on the right. All right, here we go. Our first one is called an empty set. Everyone?
Empty set.
And here's what an empty set is. It's a set with no elements shown by the symbol and those two symbols there. Those are two symbols for an empty set. Now, the symbols are important to realize, or to notice or to recognize, because you're going to see them maybe on tests or in your book, and you have to know what they mean, okay? You have to use them all the time? No, probably not this year, but you do need to recognize them. Here's what you do need to know, though, what an empty set is, and here's all that you really need to know. There's no answer or solution. Write that in your box. That's basically what an empty set is when it comes to inequalities. There is no answer or solution. You may have no idea what that means, like how does that even work, and I'm going to show you today. All right. Here's our next word, null set. Everyone?
Null set.
This is a set with no elements shown by the symbol, and of course those two symbols there, both null set symbols. Now, if you didn't recognize that, I would hope that you would. A null set is just a synonym to an empty set. Two different names for this, pretty much referring to the same thing. All right, and now comes one last one. Identity, everyone?
Identity.
So this is an equation that is true for every value of the variable. An equation that is true for every value of the variable. And that's one of those other ones you might be thinking, I don't exactly know what that means. Well, I'm going to show you in the lesson today. All right? Just where you know what that also means, right? The answer, it would respond to all numbers. All numbers would be the answer. So it's an infinite set of answers. All right, so here we go. Go ahead and grab your book. Make sure it's on page 377. All right, here we go. Number 28. All right, number 28, the directions say solve, graph each solution on a number line. So, number 28 is 20 is greater than 5 times w plus 3. Okay, now, go ahead. Put your pencils down for a second. I just want to talk about this. I'm going to do it really quickly as a nice little review, and then I'll let you write it down. Is that one of your? Yep, it is one of your guys' homework problems. So I'll let you copy it down before we go on to the next one. Okay. So when you come across problems, okay, you have to think strategically. You have to think basically one step ahead if you're going to try to make it easier on yourself. Now I have two options on this problem. I can either do distributive property on the one side on my expression and get rid of parentheses. Okay, that would give me a normal, after I did that, that would give me a normal two-step equation. right? I'd subtract 3 from both sides and then divide by 5 on both sides. Or, with something like this, and we've talked about this before, I can take this whole set of parentheses here, this whole value, and it's being multiplied with 5. Now, I'm only going to do this because I know that 20 divided by 5 comes out to a nice even rounded number. So I'm going to try to make it easier on myself. Sometimes, though, that doesn't happen. And so, therefore, I would probably want to do the distributive property. So in this case, though, right, 5 times this, I'm going to divide both sides by 5. Okay, by the way, I did not divide or multiply by a negative number, right? So our sign stays the same. And so we have 4 is greater than w plus 3. And I'm going to go ahead. We stick on the right side, right? Because that's where our w is at. Subtract 3 from both sides. And we get 1 is greater than w. Or, of course, w is less than 1. Okay, there's our solution. We can't forget to graph it. So I'll place my reference number, my 1 there. There is no equal sign, so it's a circle. W is not being eaten by the alligator mouth, right? Meaning it's smaller. So I point my arrow to the smaller numbers. And there's my graph. All right? Questions about that? I'm going to pause for a second. So the whole point of today you're going to find is that some you'll be able, there's a number of different approaches you can take on these. Some it will just kind of decide, your decision will come from what the problem looks like. Okay, kind of like our POD today with the fraction coefficients and being able to multiply, right, by the denominator. So it's just a little twist. So go ahead, I'll give you a few seconds. Go ahead and write that down, problem number 28. And then we'll go ahead and do one together. And some of this lesson, or a lot of this lesson, is a review. So talk about this. All right, anyone still copying that down? Okay, a few more seconds there. Okay. All right, here we go. Let's go ahead and let's do another one of your homework problems. Same page, problem number 32. All right, so 32, we have 3. We have 3y minus 6 is greater than 4 times, and then it's the difference of y minus 3 in the parentheses. All right, so here we go. I'll call this, I don't know, I can call it step 1, or we'll just call it step star. I'll put like this kind of little bubble where it looks a little more like a brain, I guess. All right, a little bit of mental math here. Okay, come up with an approach on how to go about solving this. So for example, right, I'm looking at this approach. If I was to box this in and divide both sides by 4, suddenly I have to divide both of these terms by 4, which would give me 3/4 y minus 6/4, or 3/2. Okay, I'm going to make that problem way too hard for myself, right? So this approach is, of course, I'm going to go about doing distributive property. So I'm going to go ahead and do that. So I have my 4 times y is 4y. And 4 times negative 3 is negative 12. All right. So step 1, I'll put a little star by step 1 because you might not have to do this if you took the other approach, but I just simplified what I could. Okay, I'm going to rewrite my inequality. All right, now it doesn't matter, but I'm going to take one of my constants and move it to the other side, either my negative 6 or my negative 12. Well, if I add 12 to both sides, this is going to give me a positive over here. So I don't know if that will work out, but I'm going to try. So I'm going to take my negative 12, and I'm going to go ahead and add 12 to both sides. Addition property of equality, right? We add both sides by the same number, we should be okay. That allows this to cancel out. So we end up with 3y, and then negative 6 plus 12 is now a positive 6 is greater than 4y. And like we talked about in our POD, right? I could have taken one of my variable terms and moved it over, and that would be just fine. All right, that's how I taught that last lesson to you guys, but realistically, you're moving constants to one side, variable terms to the other. It really doesn't matter. Okay? So if I moved my constant last time, then I'm going to go ahead and go to the other side. And I'm going to go ahead and move I'm sorry, this was step 2. Bless you. I'll put the word constant with a question mark. And this being step 3, I'll put variable term with a question mark. Step 2 and 3, guys, pretty much interchangeable. So 3y, I'm going to go ahead and subtract my 3y term from both sides. So I end up with 6 is greater than 4 minus 3 is 1y, and 1y, ladies and gentlemen. That's our answer. So 6 is greater than y, or you could say y is less than 6. Okay? Now, this here, right, is on the under the same situation that we then need to graph. So, I guess we could just say step 4 is to graph. So here we go. Remember, this is review. We have our number 6. I'll just put it in the middle. All right. And there is no equal sign, so I use a circle, not a dot. And y, right, is not being eaten by the alligator mouse. Since we're graphing the y is smaller than 6, so I'm going to point the arrow to the smaller side. And there's our graph. Okay, so multi-step inequality. I did not multiply. You know, if I would go through a little too fast, it might be a good idea to just double check. Make sure you don't multiply or divide by a negative number, right? I subtracted here, but that's not multiplying or dividing. Okay? Questions? All right, here's the one I want you guys to try. Problem 34. 34. Okay, how many of you need more time on that one? All right. Check into you guys in just a bit. Okay, who's still working on it? Okay, all right, 30 seconds, then I'm going to have you guys share. Okay, when you share, you can start with your answer. Of course, if your answers don't match, guys, compare each other's work, right? But don't forget also to share your graph, all right? So problem number 34. All right, 30 seconds. Go ahead and turn to your neighbor and share. Go.
I got R is greater or equal to 6.
Less than or equal to.
All right, here we go. All right, so problem 34, right, is 3 times the sum of 3r plus 5. And that is greater than or equal to 24 plus 10r. Okay? All right, so here we go. Just looking for some possible solutions out there. All right, I'll put my little solution box up here to record for you guys. All right, just solutions. We'll talk about the graph here in a bit. Just a solution. So seat 23. Okay. Agree, disagree. Okay. Some agreements, some disagreements. Okay. All right. How about seat 6?
I got R is greater than or equal to 6.
R is greater than or equal to 6. Agree, disagree there. Okay. Any others out there? Okay. To negative what? Negative 9. Okay. All right, well, let's check this out. Here we go. Let's see. If I divided both sides by this 3 and clear this 3 here, it would actually work on that constant, but it's not going to work there. So I'm going to go ahead and simplify. So, doing distributive property, 3 times 3r is 9r. 3 times a positive 5 is positive 15. Rewrite my problem. Okay, from here. All right. Last time we moved the constant first. This time, I don't know, I'll move the variable term first. So I'm going to go ahead and move the 9r. So this is positive 9r. I'll subtract 9r from both sides. I'll try to keep it positive. So we end up with a positive 15 is greater than or equal to 24. And then 10 minus 9 is 1. It's a positive 1r, or guess what, guys? Positive r. At this point, I go ahead and take a look, and I say, okay, well, here's our r. That's a positive 24. I'm going to subtract 24 from both sides. So this is gone. R. With that inequality sign, 15 minus 24 is negative 9. Or, of course, if I flip-flop these, I flip-flop that. Sorry, if I move down below. If I bring the r and the negative 9, I switch them. I do have to switch the sign to mean the same thing. R is less than or equal to negative 9. Now, I want to use this time here to talk about something. Some of you guys got negative r is greater than or equal to 9. Okay? Now, first of all, here's just a basic rule. That variable is not isolated. It's not by itself because we have a negative on it. And that is not going to give you an accurate answer. And let me tell you why. Because, ladies and gentlemen, that is negative 1r. r times negative 1, I need to divide both sides by negative 1. r is greater than or equal to negative 9. Okay? And then, of course, yes, sorry. Remember I said always double check. I just divided by a negative number, so guess what do we do to the sign? Flip it. So the ultimate final answer is r is less than or equal to negative 9, which should match this, and it does. So, believe it or not, this answer right here, you guys had it right, but it wasn't simplified all the way. You had to simplify it one more step. Okay? So, use that as a learning time. Don't have a negative variable as your answer. Okay? Okay, obviously, right, we have to graph it. So you had your graph, your negative 9. It does have part of an equal sign, so I put the dot. R is not being eaten by the alligator mouth, right? So it's smaller, meaning that the arrow goes to the smaller numbers, which are to the left. And there it is. Okay, questions on that? Okay, here we go. Let's go to the next. Now, what I'm going to do, I think I'm going to flip this over here and start doing them on the back. All right, so let's go ahead and let's go to page 377, which we're already there, and let's take a look at problem number 7. Problem number 7. All right, problem number 7 says 6x plus 4. Okay, oh, it's equal. So this is an equation. Is equal to 2 times 3x minus 5. Okay, here we go. I'm taking a look. I could do distributive property if I want. I'll still get the same answer, but look at this. If I divide this by 2 and divide both of those by 2, I would be okay. Both of those are divisible by 2, both those terms. So I think I'm going to do that. So I'm going to go ahead. Now watch how I'm going to show my work on this. I'm going to divide by 2 here. And watch, I'm going to divide this whole expression by 2 here. Okay? Now these two cancel out. And I'm not writing the steps because, guys, believe it or not, they're exactly the same steps that we just did. Okay? So those cancel out. So on the right side, on the expression on the right, it's 3x minus 5. Okay, now, here's a little side note. If I divide this whole side by 2, that is equivalent to doing this. Dividing both terms by 2. Okay? That there and that there's the same. Okay? So as you get older, you'll see that a lot more. So, what that means is this term here, the 6x, 6 divided by 2 is 3, so it's just 3x. And this term here, 4 divided by 2, is a positive 2. Okay, here we go. I'm going to go ahead in this one. I'm going to go ahead and take this constant of a 5. I'm going to add 5 to both sides. So we end up with 3x plus 7 equals 3x. And then I can now take my variable term, and this is a positive 3x, so I'm going to subtract 3x from both sides. That cancels. We get 7 equals, and look at this. Seven equals 0. Ladies and gentlemen, this is what an empty set looks like, or a null set. Your book sometimes says no solution. Same thing. Okay, you just depends on who you're talking to and what they'll call it. Looks a little weird, right? All right. I'm going to have you try one. Any questions?
So for the answer, we could write any of those?
Any of those would work. So when we like correct this on Friday, when you're peer correcting, just know if I forgot which ones I put up there, but you know, if it's not exactly one of those on the, it would mean the same thing. So yeah, you wouldn't mark it wrong. As long as they put one of those. If you put something like, you know, this problem has 0 answers. Okay, that's not what I want. All right, it actually kind of means the same, right? But I want to see one of these 3 though. Okay, I'd prefer you use one of these 2, just because they're obviously new terms that you're going to need to know, being an advanced 7th grader. Okay, advanced math 7 class. All right, any other questions? You stretching? All right, you got to be careful when you stretch in here. All right, here we go. This is a little different. I want to do one more with you guys. So let's take a look with this problem. Let's take a look at number 9. Number 9. Okay, here we go. We have 3 times the sum of 1 plus 2f. However, then it goes on, right? It says minus 5. That's going to equal 6f minus 2. Okay, now listen. If I divide this here by 3, that's fine, but that doesn't quite work because of this minus 5. I'd have to divide this whole side by 3, and now we're talking some differences. Okay, so here's what I'm going to do instead is I'm going to do distributive property. And again, step star, right? I'm just thinking ahead. I'm planning my, my mode of attack here, all right? So here we go. 3 times 1, doing distributive property. 3 times 1 is 3. 3 times a positive 2f is a positive 6f. I just eliminated my parentheses, right? I'm going to go ahead and rewrite. Minus 5 equals 6f minus 2. Now this side here I'm going to simplify because I can simplify. There's like terms here. There's a 3 and a negative 5. So what I end up with is 6f and then 3 minus 5 is a negative 2. Now if you don't already see it, I'm going to keep going. I'm going to go ahead, negative 2 here. I don't know, take my constant this time. I'll add 2 to both sides. That cancels, but so does that. And I end up with, obviously, well, or I could say 6f equal, and some of you guys are obviously seeing it now, right? If you want to, divide both sides by 6. Ladies and gentlemen, this is identity. I don't know who exhaled. Oh. All right. Or all numbers. That's another thing your book will say. Basically, the solution is all numbers. All numbers, because you could throw any number in for f and it's going to be equal. I mean, any number you could throw in for f and it's going to be true because each side is f. All right, you guys ready to try one? You like how I did both of those? Now you don't know which, I'm going to give you one, you don't know which one it's going to be, so. Dun, dun, dun. All right, here we go. Problem number 26. 26. Check it, I'll give you guys a minute. It might take a little longer. I'll check in with you in about a minute. How many of you still need more time on that? Okay. All right, how many of you still need more time? Okay. Those of you that are finished, you can work ahead. Just do not do numbers 50 and 52. Okay. We'll talk about those in a bit, but the rest you guys can work on while the others finish. All right, anyone still working? All right, 30 seconds. Go ahead and turn to your neighbor and share. Go.
I don't know, Nick. I think it's most set.
All right, here we go. Problem number 26. Got a lot going on, especially on the left side here. Okay? Yeah, we're getting into some advanced equations. So here we go. Advanced for 7th grade anyway. So I'm going to go ahead. What I notice, parentheses, multiplied with a 5 on the outside, a positive 5. I'm going to get rid of those parentheses by doing distributive property. So here we go. 5 times x is a positive 5x. 5 times a negative 1 is negative 5. If you got a positive 5 there, you need to make sure you start circling your terms that you're multiplying by, okay, to identify that that was a negative 1. All right, here we go. I have my 3x plus 2. I rewrite my problem, equals 8x plus 17. Notice how I'm keeping everything in line. I'm working downwards. Okay, here we go. First thing the next thing I'm going to do, I can combine like terms on this left side. So I'm going to go ahead and do that. 3x, positive 5x. Here's a positive 2 and a negative 5. 3x plus 5x is positive 8x. 2 minus 5 is negative 3. Again, I rewrite this. At this point, looking at my constants, I'm going to go ahead and I'm going to add 3 to both sides to try to keep it positive. So those cancel. I end up with 8x equals 8x plus 20. And yes, if I turn around and now subtract my variable terms over here, 8x minus 8x, this cancels, so does this. So what I end up with is 20 is equal to 0, or 0 is equal to 20. And what is that, guys? Null set or empty set, or no solution. We're taking a look at these 3 problems that I've completely filled the page up with. If someone comes to school on Friday and you go to correct their paper and they have just an answer, what do you think?
They copied.
Yeah, they either copied. Maybe they have their work, give them the benefit of the doubt, ask if they have their work on another paper. But yeah, guys, there's a lot of work involved. That's my whole point. So make sure you show your work. You need to start. I've been talking about it all semester long or all year long. Stay organized with your work downwards, okay? If you're just scratch papering all over the place and not staying organized, you're gonna lose yourself in your problem, okay? So make sure you stay organized, okay? They're actually only gonna get larger, okay? We actually have larger ones in this school year, so. Okay, any questions? 26, okay. Let's talk about one more type of problem. And that last problem, I'm not going to be able to squeeze it in here, I don't think. So I will use another paper. All right, so this problem is slightly different. Let's go ahead and read the directions to problem number 50. Okay, so 50 is on page 378. 378. So flip 378 if you're not there. Okay. Now, let's go ahead and close read the directions since they're so important. Here we go. It says, solve. Justify each step in the solution. Use a property of equality or inequality when necessary. Okay, so here's what you're going to do. Okay, you only have 2 problems like this, and we're going to do one together right now. Okay, what I want you to do is find a piece. It could be at the bottom of your page right now. Write this out. Make sure you have some room below it. You always want to make sure you have room below whichever problem you're doing, right? Okay, but this one you want room to the side, because here's what we're going to do. We're going to build a chart. And we're going to solve part of this. Every time we do, we're going to go ahead and put a line underneath. Okay? Now I'm going to just overgeneralize the steps. So here we go. Step 1 is go and start your problem. Okay? By the way, we'll call this step star. This right here, this problem was given to you by the book, right? So your justification is just going to be the word given. Given. Okay? When you get down to the end of this chart and you get your answer and you say given, that would be saying that you cheated and someone gave you the answer. So this is the only time you write given is when the book gives it to you. All right, here we go. So, step 1 is, coming back to step 1 is, I'm going to go ahead and simplify a part of this just once, one go around. Okay? Now listen, I have a couple of different options I can pull here. Okay, I could do distributive property on both sides, and if I did it, guess what? Justification would be distributive property. Or I can divide this side by 2 to get rid of the 2, and this side by 2. Okay? Now, I tell you what, for the sake of getting a little more distributive property practice, I'm going to go ahead and divide I'm sorry, I'm going to go ahead and do distributive property. So I'm going to go ahead and go 4 times y is 4y. 4 times a negative 3 is negative 12. I'm even going to do it to the other side at this point. 2 times 3y is 6y. 2 times a positive 10 is positive 20. I'm going to go ahead and write for my justification distributive property. Okay, so that is step 2. Justify, and it is required on these 2 problems. Okay, all you're doing is you're labeling which skill you just used that you've been taught this year. All right, here we go. Step 3, and here's all I'm going to put. Repeat step 1 and step 2. You're just going to do it over and over again until you get your answer. So, by the way, we're making a chart, so put a line underneath. We're making a table, I should say. All right, from here, here's what I'm going to do. I'm going to go ahead and I'm going to start with my constants, and I'm going to go ahead. If I subtract 20, it's going to give me a negative. I'll just go ahead and add 12 to both sides. And so I end up with 4y is equal to 6y plus 32. Okay, now, here's what you need to know, okay, as an advanced 7th grader. This is what can pop up on state tests, can pop up on your, any of your tests you take. This is part of what you need to know. And that is it's just called properties of equality. And what we just did was the addition property of equality. So here's what the addition property of equality says. It says, if you add both sides of an equation by the same number, both expressions, both sides remain equal. Guess what subtraction property of equality says? You subtract both sides by the same number. Multiplication. If you multiply both sides by the same, it actually is non-zero number, not a 0, but if you add both sides by a non-zero number, both sides remain equal. And the same thing for division. Okay, those are called properties of equality. So here's what I just did. I just did the addition property of equality. Put your line underneath. And let's do step 1 and step 2 again. Here we go. I'm going to go ahead, and from what we already know, I am going to now get my variable term over here. I'm going to go ahead and subtract 6y from both sides. And this gives me a negative 2y equals 32. Whatever you do to one side, you do to the other, but we use subtraction. Even though it's a term, I use a subtraction. So subtraction property of equality. Put a line underneath. All right, right here, I have my y. It's being multiplied with negative 2, so I'm going to divide by negative 2 here and negative 2 here. Those cancel, so we'd end up with y is equal to, and then 32 divided by 2 is 16, but of course positive divided by a negative is a negative 16. And ladies and gentlemen, we just did what? Division property of equality. Now, there might be times where when you simplify, you have to combine like terms. If you combine like terms, you're right, combine like terms. Okay? So you'll come across some other things other than that, right? If there's an inequality, it would be called the subtraction property of inequality. The division property of inequality says, of course, if you, and same thing with multiplication, if you divide both sides, and if, of course, both sides are a negative number, then you also flip the sign. So make sure you do that, and also make sure that it isn't of equality if you're dealing with an inequality. Okay? All right, questions on that?